Hello students, welcome to the next lecture on the Fourier series. Today I will explain you how you can find the Fourier series of the trigonometry functions. Myself Dr. Harishgar. You can subscribe my YouTube channel where you can find the various lectures related to the mathematics too. Now what we have discussed in our last lecture, we have defined the Fourier series. We have computed the half range series for the function f of x, which are defined like this manner. For more detail about this, you can follow my YouTube channel and watch my these two lectures related to the Fourier series and half range Fourier series. I hope you can subscribe my YouTube channel so that you will get the notification in advance. How you can find the Fourier or half range series? We will find the Fourier series by using this formula. Here your target is to find the value of a0, an and bn. If you closely look about all these examples which I have explained in these 10 plus 10 examples, all of the function f of x are of my polynomial nature. Now in this lecture we will cover all those functions when the trigonometric function is present in terms of the f of x. How you can find the Fourier series when the function involves sine, cosine or any of the other terms. Now remember that your target is to find the a0, an and bn always. Fine. In addition, remember, in addition to finding the a0, an and bn, whenever the function involves the trigonometric parts, then you need to find, what is the coefficient of the x? 1. What is the coefficient of x? 2. Coefficient of x? K. Fine. So you need to find the value of a1 and b1 separate. Fine. It means you firstly find the a0, you firstly find the an, you firstly find the bn as we have defined in our last lectures. And then in addition you have to find the value of a1, you have to find the value of b1. In this case this is my 2, coefficient of x is my 2, so you need to find the a2 and b2 separate in addition to the a0, an and bn. Similarly for the sine kx, you need to find the value of ak and bk separately in addition to the a0, an and bn. I hope you can like and comment on this video. What is the rule behind that? Very simple. You firstly check in each of the problem whether all those examples I have explained in this lecture, you have to firstly check if the domain is from minus L to plus L. Fine. It means it may be from minus 1 to plus 1. It may be from minus pi to plus pi. If the domain is from minus pi to plus pi or minus L to L, you always check whether the function is even, odd or none of them. If the function is even and odd, then you can easily convert into the half range series. And if the function is not an even, neither the even nor the odd, then you have to find the a0, an and bn complete. Now let's see how you can solve. I have explained the 7 examples in this lecture so that you can easily learn the concept. Firstly, I hope you can subscribe and like my YouTube channel. Now first thing, you can see the range, the domain is minus pi to plus pi. So your first step will be check whether the function is even or odd. Now we all know the mode function is always even function. Fine. Now clearly say if you read the statement, they are talking about the Fourier series. Are they talking about the half range series? No. Fine. So what is the meaning of the Fourier series? You have to find the a0, an and bn. What is that? It's a 2n pi x divided by the range, that is a 2 pi. You all know in my last lecture you have to find the series as b minus a. B is my pi, a is my minus pi. So it's a 2 pi, 2 pi will be cancelled out, it's a ns. Now since the function is my even function, what does the meaning of the even function? That means your bn will be 0. So once bn will be 0, the Fourier series becomes my a0 plus of this one. Now your target is to find the value of a0, your target is to find the value of an. Now since is a function of the trigonometric function, what is the coefficient of the x? 1. So you need to find a1 also. So this is your required target. Remember, when you have the function which is of the polynomial nature like x square minus 1x, then you need to find only a naught and an. Also, you can see this function is my even function, so you have to convert into the half range series. Now you can see here this is my cosine, you have to convert into the cosine series. Look at that, the function is from my 0 to pi, and the function is my cos x. In the first quadrant, cos is my positive, in the second quadrant, cos is my negative. So that means this value has a two possibilities. One is a cos x, second is my minus cos x, depending x lies between 0 to pi, minus pi to plus pi. Now once it is a half range cosine series, you all knows how you can find the a naught and al. So it is my 0 to L fx cos nx, and it is my 1 over L 0 to L fx dx. So remember, the domain is my minus pi to pi. Once you change into the half range, the domain will be my 0 to pi. Half range will always start from the 0. So what is the L? If you compare them from the 0 to L, L will be my pi. I can substitute this value, you will get this term. Now I can break this interval from 0 to pi by 2, the value is my cos x, and pi by 2 to pi, this number will be this quantity. Now can you integrate them? What is the integration of the cos x? It is plus sin x from 0 to pi by 2 minus it is sin x from pi by 2 to pi. Now you can substitute the limits. What is the limit of the sin pi by 2? 1, sin 0 0, minus I can take 1 over pi common, sin pi is a 0, sin pi by 2 is my 1. So if you open this bracket, it will be my 2 over pi. Then your target is to find the an. An will be 2 upon L, this one. Remember, your target is to find the a1 also. Why? I will explain you in this case. Now how you can solve that? You can multiply by 2 divided by 2. Fine. So what is the formula for that? 2 cos A cos B. So you have to apply the formula for that 2 cos A cos B, that is a cos A plus B plus cos A minus B. Now can you integrate them? What is the integration of the cos 1 plus x? So this will be cancelled out, it's a 1 over pi. What is the integration of the cos 1 plus nx? It's a cos, that is a sin 1 plus nx over 1 plus n. Similarly, what is the integration of this? 1 minus n divided by 1 minus n from 0 to pi by 2. Now you can substitute the limit. If you substitute this limit, the first value will be pi over 2 plus n pi over 2. So what is the value of this? It lies in the second quadrant. Second is a cos sin positive, so it's a cos n pi by 2. When you substitute the upper limit, it's a cos n pi by 2. Similarly for this value, when you substitute this value as pi by 2, it's a pi by 2 minus pi by 2x. Sin 90 minus this is cos pi over 2x. Similarly, if you substitute 0, sin 0 is a 0, and you get this result. Clearly say 1 over pi is a common, cos n pi over 2 is my common. Then the requirement will be this. It is a minus minus plus, it's a twice, plus twice of 1 minus n. Now you can see it's a n pi over 2. If you take the LCM, it is my 4 over 1 minus n square. So your result will be, provided n is my not equal to 1, because if n is 1, it's a 0. Fine. Now you get the an. Now you have to find the a1. So what is the formula for the a1? You remember what is the an is? 2 upon pi 0 to pi fx cos nx. This is the formula for the an. Now what is the a1? If I take n is my 1. Again I can break this interval into the two parts, pi by 2 and pi by 2 to pi. What is this quantity? It's a cos square x. How you can integrate them? I can write this is 1 plus cos 2x over 2. Similarly for this, 1 plus cos 2x over 2, and this 2 will be cancel out. Now I can take the common 2, it will be cancelled out. It is 1 over pi. What is the integration of this? X plus sine 2x over 2 from 0 to pi over 2. Similarly for this, x plus sine, or I can take x by 2, or otherwise 2 will be common. Now you can substitute the value of pi by 2. This number is my pi over 4. It's a sine pi. Sine pi will be 0. If you substitute 0, 0. Minus, I can take 2 over pi common. It is my pi over 2. Sine 2 pi is a 0. It's a pi by 4. Sine pi will be 0. Now you can see this number will be cancelled out. This number will be my minus 1. It will be, why is there something error? It's a pi by 2. It's a pi by 4. It's a pi by 2. It's a 0. It is, so where is the error? This is minus plus, because if you substitute lower limit, it's a negative. So this number will be, so it will never be, it's a pi by 2, pi by 4, it's cancelled out. So the result will be 0. Now, so you got the an, fine. So I can substitute the value of a1. So I can write this series as a0 is a a1. I can separate this, is a cos x plus n varies from 2 to infinity, an cos nx. So a1 will be 0. So I can substitute, this is a 0. a0 is my 2 over pi. An will be 4 over pi, and this is the required series. Look at this another one. Again you can see the limits are from minus L to plus L. So your target is to check whether this function is my even or odd. How you can check that? I can simply check f of minus x. It is minus x cos of minus x. Cos of negative is always positive. So what does it mean? If f of minus x is equal to minus f of x, what is the meaning of that? That means f of x is my odd function. Fine. So once you know fx is an odd function, what does it mean? This means a0 will be 0, an will be 0. So this value will be 0, an will be 0. So the only term will be my fx bn sin nx. So that is my half range. That is my half range sine series. So once it's a half range sine series, I can convert this domain from minus pi to plus pi to the 0 to plus pi. Fine. Now you can see there is no need to break this interval into the two parts, because the modulus is not given to you. Now your target, what is your target? Your target is to find the value of the bn, and because the function involves the trigonometry part, what is the coefficient of the x? 1. So your target is to find the value of the bn, and your target is to find the value of b1. Now it's a half range series. What is the value of the bn? It's a 2 over L 0 to L fx sin nx. Fine. What is the L? This number is my L. Now I can substitute the value of the fx, that is the x cos x. How you can solve that? I can use this value. I can multiply by 2 and divide it by 2. So it's a 2 cos A sin B. So you all know 2 cos A sin B is sin A plus B, sin A minus B. Now how you can solve this? Now it's an integration. Either you can integrate by parts, or you remember my last lectures on the integration. How you can solve this? I can write this function. One term is my polynomial and other term is this. I can differentiate this function until it becomes a 0, and I can integrate this function. It's a minus cos 1 plus nx over 1 plus n minus minus plus cos 1 minus n over 1 minus n, and then again integrate minus sine 1 plus divided by 1 plus n whole square plus sine 1 minus nx over 1 minus n whole square. You can multiply this with a positive sign. You can multiply this by negative sign. So this number will be minus x cos 1 plus nx plus x cos 1 minus nx minus minus plus sine 1 plus nx and minus plus minus of this number is sine n plus 1 x. Now you can substitute the limit. When you substitute pi, what is this number? It's a pi. So this number will be cos, if I open this, is a pi plus n pi. So what is that? It lies in the third quadrant. It's a negative minus cos n pi minus minus plus pi cos n pi. And we all know what is the value of the cos n pi, minus 1 raised to power n. Similarly for this, divided by 1 plus n, it is pi. This is my pi minus cos, so again it's a negative, so this number is my minus cos n pi over 1 minus n. If you substitute pi, sine pi will be 0. It's a pi, sine n pi will be 0. Similarly, if you substitute 0, it's a 0. This is 0, sine 0, 0, sine 0, 0. So this number will be my this one. Now you can take pi as a common. It will be cancelled out. Minus 1 raised to power n common. The remaining quantity remains my. Now you can take the LCM. It becomes my 2n minus 2n over 1 minus n square into minus 1 raised to power n. Clearly say n is my not equal to 1. Now your target is to find the value of the b1. I can substitute n is my 1 in this case. So it's a sine x. I can substitute the value of the fx. What is that? I can multiply by 2 and divide it by 2. Then this value will be my sine 2x over 2. How you can integrate them? I can write the x and the sine 2x. 1, 0. It's a minus cos 2x over 2 minus sine 2x over 4. I can multiply this with a positive sign, this with a negative. So it's a minus x cos 2x by 2 and this number. I can substitute the limits. If you substitute pi, cos 2 pi is a 1, sine 2 pi is a 0. If you substitute 0, 0 is a 0. So pi and pi will be cancelled out. Answer is minus 1 over 2. Now you calculate the bn, you calculate the b1. So I can substitute this value in this expression, b1. When n is equal to 1, this is my b1 plus summation n is equal to 2 to infinity bn sine nx. So I can substitute the value of the bn that I have computed, which is given to be this number. Make sure you have to change n is my 2. I hope you can like and subscribe my YouTube channel. Look at this another question. Again, the limit is my from minus pi to plus pi. But can you say this function is my even or odd? You can never say, because they are the two parts. One is the 0 and second is the sine x. So it is neither the even nor the odd. So what does it mean? Your target. So what is your target? Your target is to compute the a naught, an and bn odd. Also the coefficient of the x is 1. So your target is to find the a1. Your target is to find the b1. So in this problem, your target is to find these 5 numbers. Now since it is not a Fourier half range, is it a half range? It is not given to you, so it is not a half range. Then what is the value of the a0? From minus pi to plus pi, fx dx 1 over range b minus a. What is the an is? An will be 1 or you can say 2 over b minus a. Fine. Minus pi to pi fx cos nx. So let's start with the a0. I can substitute the value of the fx. I can break this into the two parts. From minus pi to 0 is a 0 and then 0 to pi this way. Now can you integrate the what is the integration of the sine x? The integration of the sine x will be minus cos x. Now can you substitute the limit? What is the cos pi? Minus 1. So minus minus plus 1. When you substitute lower limit 0, cos 0 is my 1. So 2 and 2 will be cancelled out. This number will be 1 over pi. So your a naught will be 1 over pi. Now I compute the an. I can substitute the value of the fx. Again I can use the formula for that 2 sine a cos b. I can multiply by 2 and divide it by 2. So 2 sine a cos b, that's a sine a plus b, sine a minus b. What is the integration of the sine? It's a minus cos n plus 1 over 2 over 1 plus n. If you substitute pi, this is minus pi plus n pi. Fine. What is the pi plus n pi? It lies in the third quadrant. It's a negative. So minus minus plus sine n pi. Sorry. It's an even function. It's a cos n pi. Fine. So cos n pi will be my minus 1 raised to power n. Similarly, if you substitute pi, this number will be my cos pi minus n pi. So it lies in the second quadrant. Second quadrant cos is a negative, minus cos n pi. So it's a minus raised to power of this. When you substitute 0, cos 0 is a 1, so minus minus plus and minus minus plus now. Fine. Or you can write instead of this, you can write as a cos n pi. Now you can take 1 plus n and 1 plus n as a common. So what will happen? 1 plus n, then it is 1 this number. Similarly for the 1 minus n of this number. Now you can take 1 plus this as LCM, or you can write it 1 plus minus 1 raised to power n is a common, and the inside term is 1 plus n and 1 minus n. Now take the LCM. This is 1 minus n square of 2, and this number will be over 2 pi. So 2 and 2 will be cancelled out. The final result will be 1 plus minus 1 raised to power n divided by pi of this number. Clearly say n is my not equal to 1. Then your target is to find the a1, because the angle is my 1. I can substitute the value of n1 in this expression. Again I can substitute the value of fx. I can multiply the 2 and divide it by 2. Then what is the integration of the sine 2x minus cos 2x over 2? What is the limits of this? So 1 over 2 pi, cos 2 pi 1, cos 0 1. So you can see minus half plus half, it will be 0. So a1 will be my 0. Now your target is to find the bn. So bn will be your fx sine nx. Again I can substitute the value of fx from minus pi to 0 and 0 to pi. I can multiply 2 and divide it by 2. I can apply the formula for that 2 sine a sine p. Then what is the integration of the cos n minus 1? So cos integration is a sine 1 minus n of x divided by 1 minus n, and it's a sine of 1 plus n divided by 1 plus nx. Now I can substitute this value. If I substitute pi, this number will be sine pi minus n pi. It lies in my second quadrant. It's a sine of n pi. Sine n pi will be 0. First value will be 0. Similarly for the second case, 0. When you substitute lower limit, sine 0 is a 0 and sine 0 will be 0. So this bn is my 0 for all, which is all those n but not equal to 1, because when n is 1, this is undefined. Compute the value of the b1. Substitute this. How you can solve the sine square? So sine square will be 1 minus cos 2x over 2. Then I can integrate this part. What is the integration of this? Integration of this is my x. It is my sine 2x over 2 from 0 to pi. Now you can substitute the limits. What is the limit of pi? It's a pi. Sine 2 pi is a 0. When you substitute 0, and it is a 0. So the answer will be 1 over 2. Fine. So what we have computed, bn is my 0, b1 will be half, a0 we have computed, an we have computed. So I can substitute all those values in this given expression. You can see a0 is my 1 over pi, I can take n is equal to 1, so a1 is 0, so cos 0, b1 is my half, so b1 sine x, so this is a b1 sine x, and the rest of the expression taken from n is equal to 2. An is my this, bn is my 0, so this is the right answer of this problem. Again, you can see, is it an even and odd function? No, not an even or odd function, because limits are not from minus pi to plus pi. So what is your target? Your target is to compute the a0, an and bn. Angle is my 1. Your target is to find the a1. Your target is to find the b1 also. Again, your target is to find these three parameters. So that I will give you an exercise for you. You can solve this and let me know your answer in the comment box, that whether you have obtained a0, an and a1 this, b0, bn and b1 like this. So once you can solve this, verify your answers and let me know in the comment box that yes, you can obtain or no. And finally your answer will be this one, because a0 is my minus 1, so I can substitute a0 is my minus 1, a1 is a minus 1, I can write this is a1 cos x plus b1 sin x plus summation n varies from 2 to infinity an cos nx bn sin nx. I can substitute all those values. So you can put your answer in the comment box, and hope you can like and subscribe my video too. Look at this next example. You can see it's a minus pi to plus pi. So check whether this is the even function or the odd function. So clearly say mod of x. Mod x is always my even function. So that means if mod x is my even function, so bn will be 0. So that part will be my 0. So your target is to find the a0, an. Angle is my 1. So your target is to find the a1 also. Fine. Now once it's an even function, so you have to convert this into the half range series. So what is the half range series is? You have to write this domain to 0 to pi. So what is the meaning of that? This is my 0, this is my pi, and it's a sin x. Sin x in the first quadrant is a positive, sin x in the second quadrant is also positive. So I can say this number is my single sin. Then now I can find the a0, substitute the value of the a0, that is fx, from 0 to pi. You will solve this integration, you will get 2 over pi. Similarly, you can compute the ban. I can substitute the value of the fx as a sin x. I can multiply by 2, divided by 2. I can apply the formula for the 2 sin a cos b. I can integrate the sign of this. What is the integration of the sign is? Minus cos this value. Now you can substitute this limit. It's a minus cos. When you substitute pi, so this is pi plus n pi. It lies in the third quadrant. It's a negative. So minus minus plus cos n pi. Cos n pi will be my minus 1 raised to power n. Similarly, this number is my minus 1 raised to power n over this number. If you substitute 0, cos 0 is 1. This number, cos 0 is a 1 of this number. Fine. Now you can take the LCM. This number is my minus 1 raised to power n. I can take this and this as the LCM. Now you can take minus 1 raised to power n over pi as a common. The remaining quantity will be this part. Now you can see, if you take the LCM, it will be my twice of 1 plus divided by pi, and this number is provided n is my not equal to 1. If n is not equal to 1, we have to compute the a1. Again substitute the value of the fx. Can you solve this integration? It is my sin 2x. Fine. I can multiply by x. I can multiply by 2 and divide it by 2. Then it's a sin 2x by 2. What is the integration of the sin 2x? It's a cos 2x divided by 2 from 0 to pi. What is the cos 2 pi? cos 2 pi is a minus 1, is a plus 1, and if you substitute 0, it is my plus 1. Again, it is my 0. So a1 will be my 0. Now you computed the a1, you computed the a0, an you have computed. Substitute all these values in this expression. I can write this is my a1 cos x plus summation n varies from 2 to infinity an cos nx. Substitute the value of a0, a1 and an. a1 is 0, so this whole quantity will be 0 is the right. Okay, look at this next one. Obtain the Fourier cosine series. It is already given to you that you have to find the cosine series. What does it mean? That means they are talking about the half range series. Fine. They are talking about the half range series. So this number will be my L. Is a cosine. Again you can see the sine term present. Angle is my 1. So your target is to find the a0. Your target is to find the a1 also, and your target is to find the an as well. Now let's see a0. What is the a0? We all know how you find the a0 is 1 over L, 0 to L, fx. What is the an? 2 over L, 0 to L, fx cos nx. Fine. Otherwise, you all remember that the general formula will be n pi x over L. In this case, L is my pi. So, pi and pi will be cancelled. Now, substitute this value. What is the integration of the sin x? This number. So, if I substitute cos pi is a minus 1 and cos 0 is plus 1. So, this number will be my 2 over pi. I can find the an. I can substitute the value of the fx. I can multiply by 2, divided by 2, then 2 sin a cos b. What is the integration of the sin 1 plus nx? Minus cos n plus 1 nx. Now substitute this value of pi. This is minus cos pi plus n pi. It lies in the third quadrant, is a negative. So minus minus plus cos n pi. What is the value of the cos n pi is? Minus 1 raised to power n. Similarly, if you substitute this number, it is minus cos pi minus n pi. It lies in my second quadrant. Its second is cos negative, so minus minus plus cos n pi. Again, cos n pi will be minus 1 raised to power n. Then I can substitute the 0. Cos 0 is 1 and cos 0 is my 1. Then I can take the LCM of the 1 plus n and I can separate the 1 plus 1 minus n. So you can see this term over 1 plus n and this term of 1 minus n. I can take this numerator as a common and you can take the LCM and you will get an is my this one. Now your target is to find the a1 also. I can substitute n is equal to 1 in this expression. So you will get this term. Substitute the value of the fx. This term sin 2x divided by 2. What is the integration of the sin 2x? Minus cos 2x over 2. When you substitute pi, cos 2 pi is 1. If you substitute 0, minus cos 0 is 1. So clearly say this number is my 0. So substitute a1 is my, so substitute all these values in this expression. So you will get a1, I can write this is a0, a1 cos x plus n varies from 2 to infinity an cos nx. This value will be 0 because a1 is my 0. I hope you can like, comment and subscribe my YouTube channel. You can share this video with your friends also. We will see the next lecture on the wave equations. Till then, you can like, share and comment on this video. Best of luck students. Happy learning.